Let's talk about good news first. So lunch is next. Bad news is you'll have to bear with me for about like 10 more minutes. So short summary of my talk is that you all heard Alex say to talk about PPF is that all I want is I want PPS for iOS. I don't have it. It makes me sad. So that's a short summary. My name is Gunnar. I've been at Facebook for 4 years, the last 2 years working on iOS performance. Before that, working 2 years on database kernel performance, and before that, a long time at Microsoft. So welcome, my ex-colleagues from Redmond. So let's talk about iOS. What do you have to do to work on iOS, actually? So this climb took 2 days. It was heavy, it was hard, it was scary. I was terrified for a bunch of moments. So that's how I sometimes feel when I work on iOS. And you may ask me why. So at some point, we hit performance problems which require understanding how memory manager works, how loader works, what do I/O drivers do, like how is file system set up, what's really going on inside the system. And this talk is mainly about what it takes to get this understanding for iOS. Like if you work on Linux, or even if you work on Windows, you're pretty much very, very spoiled. My friends make fun of me and they say, well, you're now just an application developer. You're no longer an operating system developer. But the problems we have are the same. We still need the same information. The only difference is we just don't have it. So let's take a look at iOS. Documentation. There's literally one person writing detailed technical books about iOS. His name is Jonathan Levin. If you pretty much do anything related to iOS, buy his books. They are the best. Linux, you can pretty much read everything. You can look at all the documentation. It's all good. Windows, very well documented, both user mode and kernel mode. Source code. Apple has published some parts of GNU kernel, and some user mode components are published. Linux, of course, you can download everything, you can compile everything, you can breakpoint everything, literally almost everything except proprietary drivers. And actually, contrary to popular opinion, even Windows has shared source programs. So if you work for government, if you work for a big enterprise, there's tons of stuff you can do with Windows. Builds. So ideally, as a performance engineer or any type of systems engineer, you want debug builds. Why? Debug builds give you extra information. You see the assertions, you see the traces, you see all kinds of timeouts. You can get some more insight. So let's look at iOS. What you have is pretty much signed release builds. For Linux, of course, you can build anything you want. You can do whatever you want. Life is good. Windows, you can actually get debug builds. You can get release builds. So it's kind of also pretty good. Not ideal from external point of view, but pretty good. Now, people think about that, hey, Facebook has Instagram, WhatsApp, Messenger, Facebook application. Why do you need to have anything to do with like non-user mode? Well, simple answer. We hit the problems which will require us understanding what's going on a file system, what's going on with other processes, what's going on with a memory manager, why do we have some lock convoys, why do reader-writer locks take a certain path, why tracing happens in a certain way, and it's extremely hard to do it while we're isolated to like one process only. Like most of the sad debug stories end up as like looking at kernel source code, trying to figure out something from tracing, and then kind of speculating that, it seems that this code, source code path was taken. So compare this to operating system where you can actually kind of build everything, or even in Windows, like you can have a kernel debugger attached, you can look at some things and kind of figure out what's approximately going on. So now, toolset. Apple has the best toolset for iOS, like no question here. Everything is integrated, everything is very smooth, life is good. Linux, you can implement anything you want. Write your own debugger, write your own profiler, write your own file system, like do anything you want. Windows, kind of good way to replace a bunch of system components. Can have your own profiler, can have your own memory manager. Like typical exercise for system developers is to write their own debugger. So this is whiteout. Again, this is like you're in mountains, you don't see anything, is everything lost? Nope. We can still do a bunch of useful stuff on iOS, based on documentation, based on tools, based on some sort of tribal knowledge we can pick up from internet. Let's look at kind of empirical lessons, what we've learned at Facebook. About 75% of the tool set some of us are used to is kind of off limits. So for example, most my teammates and I come from a background where we kind of used to building our own kernel, like looking at file system, putting breakpoints in memory manager, replacing all kinds of components, enabling all kinds of tracing, doing all kinds of stuff like this. This is kind of all gone on iOS. So which kind of makes it interesting. Like, you want to work on something hard, don't work on Android, don't work on Linux, don't work on Windows, come and work on iOS. Performance-wise, at this point, I think we are pushing pretty much the boundaries what we can do on a device. We have lots of users, we have lots of functionality, and we have lots of problems. And some of these problems literally force us to go back to basics. How do we save a millisecond here? How do we save a kilobyte here? How do we save like 10 page ins, page outs? How do we save like writes? How do we do something like this? So in some ways, it's a very good forcing function to kind of go and solve all those hard problems. Now, what we've also found is that the only thing which matters is what happens on the device. Apple has an excellent environment. You can run a simulator. You can do tons of measurements. You can do tons of profiling. But what it really comes down to is hardware is different from a simulated environment. And we made lots of mistakes in the past by kind of making some sort of approximations or decisions which said, hey, listen, this seems to be working fine. But once you have CPUs running somewhere, once you have people actually using things, everything is different. Getting kind of more illuminated or educated is complex. Currently, we're just pretty much looking at black hat presentations, reading some of the books, and kind of trying to guess what's really going on. But, I mean, one thing which saves us is, at the end of the day, pointer is a pointer, like malloc is a malloc, thread is a thread, page fault is a page fault. So it's pretty much the same stuff, just kind of in a more limited environment. So, we are not doomed. Like, things will go on, we'll fix our issues. It's just kind of, one of the things to think about is if you see somebody working in an iOS space, like my friends occasionally come over and say, hey, we had this huge performance win, we replaced, I don't know, this part of the file system, or we did this cool thing with tracing. And then I just look at them and I'm sad and said, I cannot do it. Or they said, hey, listen, have you tried this? We did this cool thing with preloading or optimization or changes other things. And I'm like, okay, I'm sad, I cannot do this, but I really want to. But what will make us happier? This is kind of tons of asks. First of all, detracing, symbols, ability to actually SSH into iPhone, expose memory graph APIs, and maybe kind of get some more recent versions of source code. And what I mean by more recent is like, whenever Apple upgrades their operating systems, things change. And for us, even those small things matter. Like, okay, some part of behavior changed. Maybe we can optimize something here. We can design some parts of our code just to kind of save 10 milliseconds here, 2 kilobytes here, 10 page faults here, and do stuff like this. But given that lunchtime is coming, I'll leave you kind of with a key piece of guidance if you do any type of performance engineering. This is kind of probably the most useful guidance I received in my career. Just don't do anything. Don't call any functions, don't allocate any memory, don't start any threads, don't load anything. And kind of if you follow this guidance, your product will be solid, it will be performant. It probably won't do anything, but performance-wise, you won't have any problems. Okay, any questions?